Hey everyone, you finally learned about verbals, so from now on, we'll probably be creating them in pretty much every lesson. And that means today we've got a whole 8 exercises to work through. We now know how to create a data and print it to the screen. Once we learn how to get input from the keyboard and store it in our variables, that's when things are really going to get crazy with the exercises. Try to solve these exercises on your own first and then see how I did them. Let's get started. Exercise 1. Create one variable of type int, store your favorite number in it, and print it to the screen. For example, my favorite number is 7. The first 3 exercises are going to be pretty similar. In the first one, I create an int variable because I want to store the whole number 7 in it. Then I assign that number to the variable. After that, I print some text to the screen followed by the value of the variable. Notice the name I gave my variable. The name should make it clear what kind of value is stored inside. Let's run the program and see what we get. Exercise 2. Create a variable to store the air temperature with the fractional part. Print it to the following format. Temperature 24.5 C Celsius. The code here is similar, except this time the variable is a double because we're working with a decimal number. I assign the value to the variable and then print some text followed by the value of the variable and finally the letter for the temperature unit. The variable name is also pretty self-explanatory here. Let's run it. Exercise 3. In a game, a character belongs to a class represented by a single letter. Create a variable of type char, store, for example, the character A in it, and print character class A. And here we have a similar exercise, except this time we're using the char type. We assign the letter A to it and print the text to the screen. And once again, pay attention to the variable name. It clearly describes what the variable represents. Let's run it. Exercise 4. Create a Boolean variable that indicates whether a door is open. Print its value. Then change the door state to the opposite value and print it again. Example, door open 0, door open 1. Here we actually need to change the value of a variable. First I create a variable of type bool. Why bool? Because a door has only 2 states, open or closed. So a bool is a perfect fit for this. Next, I have a rule. I try to name bool variables using prefixes like is, was, or has, followed by a noun or an adjective. In this case, I use is door open. The door is closed at first, so when we print the value, we'll see 0. Then I change the variable to true, which means the door is now open. When we print it again, we'll get 1. Let's run it. Exercise 5. Create a variable volume with the value 20. Print volume 20, then assign 50 to it, and print it again. Finally, assign 100 and print it one more time. Volume 20, volume 50, volume 100. Here we need to change the variable twice. I create the variable and initialize it with its starting value. Then I print its value to the screen, change it, print it again, change it one more time, and print it again. So each time we're going to get a different value. Let's run it and see what we get. Exercise 6. An object is located at a certain point in a 2-dimensional world. Create 2 variables for its x and y coordinates. Initially, the object is located here. X equals 10, y equals 25. Then change both coordinates. X equals 40, y equals 15, and print them again. Here we're working with 2 variables. Since these variables are closely related, they're both part of the same thing, the coordinates, and they also have the same data type. I declare them together, separated by a comma. Then I print their values to the screen. We'll see 10 and 25. After that, I change the value of each variable and print them again. This time we'll see the new values. Let's run it and see what we get. Exercise 7. Create variables to store the file size in megabytes, the download percentage, the first letter of the file extension, information about whether the download is finished. For example, file size is 850 megabytes, download progress is 70, extension letter is M, and finished 0 or 1. Now, there is actually something worth discussing here. First, we need to create 4 variables. Notice that I separated the block where I create them with an empty line. Next, we need to figure out what to name this variable so that the names aren't too long but still clearly describe what they represent. The first variable is file size. Does the variable name tells us what unit we're using for the file size? No. So soon we're going to learn about something called comments, and we'll be able to use them to provide extra information like this. But for now, we need to solve the problem without them. According to the exercise, we're using megabytes, which are usually written as MB. So I could add those 2 letters to the variable name. Does that make the name a little uglier? Yeah, but not too much. It's still a pretty short name. We have a similar problem with the second variable. What does it mean when we say that progress is 70? What exactly does that 70 means? What does it represent? From the exercise, we know it means 70%, but there's nothing in the code itself that makes that clear. Normally, it would be better to use a comment to provide that extra information, but we haven't learned about comments yet, so we'll skip that for now and keep the current name. I wouldn't add the word percentage here because it's pretty long and it would make the variable name too long to look clean. It's a compromise. I don't have any issues with the third variable, but I do have an issue with the fourth one. What do you think is wrong with its name? The problem is that the variable name doesn't tell us what exactly has finished, so a better name would be as is download finished. I initialized each variable and printed them to the screen along with some clear text. Let's run it and see the result. Exercise 8. Create variables that describe the game settings: screen width, screen height, volume, whether vertical synchronization is enabled, the selected graphics preset, I forgot how to read it, represented by a single letter, for example H, high. Print the settings, like this. Then change at least 3 settings and print them again, for example, like this. Okay, so here we first need to create the variables with their initial values. Print them to the screen, change them, and then print them again. Nothing complicated, it's just a little more work. The main thing is learning how to give your variables good names. I like the name of every variable here. In game development, it's perfectly normal to use the abbreviation vsync for vertical synchronization because the full name would just be too long. I also want you to pay attention to how I print the screen resolution. On the same line, I print both the number of pixels in width and the number of pixels in height. You can print as many variables and literals as you want with a single cout statement. You just need to separate them using the double angle brackets. There's not much else to explain here, so let's run the program. Notice that the 2 blocks of output aren't separated, so every kind of blends together and isn't very easy to read. It would be better to use 2/n characters here instead of just 1, but since that's more than 1 character, we'd also need to change that character literal to a string literal by replacing the single quotes with double quotes. And that's it for this lesson. Thanks for watching. I hope you try to solve these exercises on your own. In the next lesson, you'll learn about constants and we'll keep practicing. See you there. Bye, everyone.